Welcome to this comprehensive guide on PyTest interview questions. PyTest is one of the most popular Python testing frameworks used in software development today. In this series, you will learn about the fundamental concepts that are commonly asked in technical interviews, including fixtures, parametrization, plugins, and test discovery. These topics form the backbone of effective test automation with PyTest, and are essential knowledge for any Python developer working with testing frameworks. PyTest is a mature and feature-rich Python testing framework that simplifies the process of writing and running tests. Unlike other testing frameworks, PyTest requires minimal boilerplate code and uses simple assert statements instead of complex test methods. Its key features include simple syntax that makes tests easy to read and write, automatic test discovery that finds your tests without configuration, detailed failure reports that help debug issues quickly, comprehensive fixture support for test setup and teardown, and a rich plugin ecosystem that extends functionality. Let's look at a basic PyTest example to understand its simplicity. In PyTest, test functions must start with the word test followed by an underscore. The first function tests basic addition by asserting that 2 plus 3 equals 5. The second function tests string operations, checking that the length of pytest is 6 characters and that it starts with py. Notice how PyTest uses simple assert statements instead of complex assertion methods. To run these tests, you simply execute pytest-testexample.py from the command line. No special test classes or setup methods are required. Fixtures are one of PyTest's most powerful features. They are functions that provide test data, setup, and teardown for your test functions. Fixtures help eliminate code duplication by allowing you to share common test setup across multiple tests. To create a fixture, you use the @pytest.fixture decorator above a function. In this example, the sample data fixture returns a list of fruits. Any test function that includes sample data as a parameter will automatically receive this data. The test function, testFruitCount, uses the fixture to verify that the list contains exactly 3 items. Fixtures can have different scopes that determine how often they are executed. The function scope is the default and runs the fixture for each individual test. The class scope runs the fixture once per test class, sharing the same fixture instance across all methods in that class. The module scope runs once per test module or file, useful for expensive setup operations. The session scope runs once per entire test session, perfect for database connections or other resources that should persist throughout all tests. In the example shown, a session-scoped fixture creates a database connection that persists for the entire test run and is properly closed using the yield statement. Test parametrization allows you to run the same test function with different input values automatically, eliminating the need to write multiple similar test functions. You use the @pytest.mark.parametrize decorator to achieve this. The decorator takes 2 arguments. First, a string containing the parameter names separated by commas, and second, a list of tuples containing the test data. In this example, the test function receives different input and expected values to test a square function. PyTest will automatically run this test 3 times, once with input 2 expecting 4, once with input 3 expecting 9, and once with input 4 expecting 16. PyTest automatically discovers tests in your project based on specific naming conventions. For files, PyTest looks for files that start with test or end with test.py. For functions, it finds functions that start with test. For classes, it discovers classes that start with test followed by a capital letter. Within test classes, it finds methods that start with test. You can run tests in various ways. PyTest alone runs all discoverable tests in the current directory. pytest-testfile.py runs a specific file. pytest-k test name runs tests matching a specific pattern, and pytest-v provides verbose output showing individual test results. Markers are decorators that add metadata to your tests, allowing you to categorize, skip, or modify test behavior. PyTest provides several built-in markers. The @pytest-mock.skip marker unconditionally skips a test, useful for tests that are not yet implemented. The @pytest-mock.skipif marker skips tests based on a condition, such as operating system or Python version. The @pytest-mock.xfail marker indicates that a test is expected to fail, useful for known bugs. You can also create custom markers like @pytest-mock.slow to group tests by category. Run specific marker groups using pytest-m-slow to execute only tests marked as slow. PyTest has a rich ecosystem of plugins that extend its functionality. pytest-cov provides code coverage reporting to show which parts of your code are tested. pytest-mock offers mocking and patching capabilities for isolating units under test. pytest-html generates beautiful HTML test reports for better visualization of test results. pytest-html enables parallel test execution to speed up test runs. To install these plugins, use pip install pytest-cov for the coverage plugin. Run tests with coverage using pytest-cov equals miproject. Generate HTML reports with pytest-html equals report.html. These plugins significantly enhance PyTest's capabilities for professional test automation. Here are the most common PyTest interview questions you should be prepared to answer. First, what are PyTest fixtures and their scopes? Be ready to explain how fixtures provide test data and setup, and describe the 4 scope levels: function, class, module, and session. Second, how does test parametrization work in PyTest? Demonstrate your understanding of the parametrize decorator and how it reduces code duplication. Third, explain PyTest's test discovery mechanism, including the naming conventions for files, functions, and classes. Fourth, what are PyTest markers and their usage? Discuss built-in markers like skip, skipif, and xfail, as well as custom markers for test organization. Master these concepts, and you'll be well prepared for PyTest interviews.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.